Hello guys, today I am Given from DIT1G. Today I want to talk about our case study 1, computer architecture. Okay, first of all we go for concept of security and protection service in operation system. Firstly, security and protection services is an operating system are the tools and rules used to keep system resources and data from unwanted access, misuse, or damage. These services guarantee that the system maintains confidentiality, which is data privacy, integrity, that is data accuracy and availability, known as access when needed, and that only authorized users or program can access particular resources. Okay, next is authentication, authorization, encryption mechanism, enhanced security system. Firstly, authentication. Authentication is the first line of defense in system security that ensures the only legitimate users can access the operating system or its resources. This verify a user identity before granting access. It also uses the common authentication methods such as password based login, which is user enter unique username and password, and biometric authentication where users can use the fingerprints, and facial recognition or iris scan, which is we call our eyes, and also two-factor or multi-factor authentication that combines something the user know as a password. Next, authorization. After a user identify is verified, authorization determines what action that user is allowed to perform. This authorization control access rights and privileges within the system. The operating system assigns permission to files, folders, application, and network resources. Authorization ensures users operate within their roles, such as regular user may read files out, cannot modify system settings, or an administrator as high privileges. Okay, next is encryption mechanism. Encryption protects data by converting it into an unreadable the text that can only be understood with a description key. It enters data confidentially even if the information is intercepted or stolen. There are two main types of encryption. One is symmetric encryption and asymmetric encryption. Symmetric encryption uses the same key for encryption and description, while asymmetric encryption uses a public key for encryption and a private key for decryption. Okay, next, I want to talk about how access control policies and privilege management protect system resources from misuse. Okay, access control refers to the methods and rules used by the operating system to manage which users a process can access specific system resources such as files, memory, devices, or applications. It ensures that only authorized user can perform specific action like reading, writing, executing, or deleting data. There are three main types of access control models used in operating system, which are discretionary access control, which is called DAC, then mandatory access control MAC, and role-based access control privilege RBAC lah. So privilege management involves controlling and limiting the level of authority or permission each uses or process as in the system.
Hi everyone, my name is Harish. Today I'm going to explain about instruction set, machine language and assembly language. Then I'll discuss about the three main groups of instruction which is used inside a microprocessor, which are arithmetic, data transfer and logical instructions. These are very important topics because they are the foundation of how a computer actually thinks and perform tasks. Let's start with the first one, the instruction set. Every microprocessor or CPU is designed to understand only a specific set of instructions. This list of command is known as the instruction set. To sum up, an instruction set is basically the complete list of commands that a microprocessor can understand and execute. Next, we have machine language. Machine language is the lowest level programming language. It is written entirely in binary code, which is made up of zeros and ones. The only language the CPU understands directly. To us, it looks complicated, just a string of ones and zeros. But to the CPU, it's clear instruction. For example, the binary code 10110000 tells the processor to move a value into a register. To sum up, machine language uses binary code, whereas the CPU understands and executes directly. Then comes the assembly language, a slightly more human-readable version of human machine language. Instead of using long binary numbers, we use short words to represent the instructions. For example, MOVAL 61H, which moves the value 61H into the AL register. Each assembly instruction corresponds directly to one machine instruction. To sum up, assembly language is a human readable version using short words. Next, I'm going to talk about the arithmetic instructions. Arithmetic instructions are used for mathematical operations such as addition, subtraction, multiplication, and division. Some common arithmetic instructions include add, sub, in, and that. For example, add AX BX adds the content of register BX to register AX. You can imagine this as the CPU's calculator. These are the basic math operations that help perform complex computations in programs. The next group is the data transfer instructions. These are used to move data between registers, between memory locations, or between input and output devices. For example, MOV AX BX copies data from BX into AX. In simple terms, these instructions are like a delivery system in the CPU, moving data from one place to another so the right information is available when needed. The third group is logical instructions. These are used to perform logical operations such as AND, OR, NOT, XOR, which are the building blocks of decision making in computers. Example, AND, NAL, 0FH performs bitwise and between AL and 0FH. Example for OR AX BX performs bitwise OR between AX and BX. XOR, example for that, AL clears the AL register, setting it to 0. Example for NOT and NOT, BL invert all the bits in BL. For example, A and D can be used to check specific bits, while OR can set bytes, and XOR is often used for comparing data. Logical operations are very useful in tasks like encryption, data checking, and decision making in progress. That's all for me for now. Thank you.
Hi, my name is Kormaran. So today I get a question. There is a medium-sized company named Technova. Solution is expanding its operation across 3 floors in a new building. Each floor houses different departments. Floor 1, administration and human resources, consists of 5 workers using laptops and one printer. Floor 2, software development and R&D, consists of 10 workers using high-spec desktops, 2 printers, and 1 server. Floor 3, customer support and sales, consists of 5 workers with desktops. Choose any network topology and visualize the network topology for each floor for Technova solution with diagram. Okay. For floor 1, we use one access point, 3 PC, and one printer below the core router firewall. For floor 2, we need 5 PC and one printer below the firewall. For floor 3, we use 6 PC below called Ruder.
Hi, my name is Devraj. Today I'm going to explain on how to find register data value from the question given. The first question is move. So we have to move the lowest bit from the register data 0 to register data 1. The second question is add. To add the data, we must add the data 0, register data 0 and the register data 1 so that we can get the answer in hexadecimal. The third question is subtraction. We must subtract the register data 0 to register data 1. We will find the value of data register 1. Question number 4 is about multiplication. The multiplication of word is contained of 16-bit number. Question number 5 is about division. The division of word contains of 16 bits number to change the to get the value of register data 1. Question number 6 is about n. N is you can found in a truth table of gate n. The seventh question is OR. OR is logic gates that using you must use a truth table to find the gate OR. Question number 8 is exclusive OR. It contains a logic gates that using a truth table of exclusive OR. That's all from me. This is the code that execution after the register of the data register.